In this video, I'm going to show you another very cool project which is called as Megalodon. Megalodon is an improved mega architecture with multiple novel technical components, including complex exponential moving average or SEMA, the time step normalization layer, normalized attention, and pre-norm with two-hop residual configuration to improve its capability, efficiency, and scalability. Through a direct comparison with Llama 2, Megalodon has already achieved impressive improvements on both training perplexity and across downstream benchmarks. Llama 3 is on the horizon, so I'm not sure if this would be valid then, but as of now, today, this is valid. Importantly, experimental results on long context modeling demonstrate Megalodon's ability to model sequence of unlimited length. Additional experiments on small medium scale benchmarks across different data modalities have also shown that the robust improvements of Megalodon, which lead to a potential direction of new fine-tuned models based on this Megalodon for large-scale multi-modality pre-training. They have made public all the source code of this Megalodon so that if you are interested in training it or fine-tuning it, you can simply do it. They have also released this Megalodon 7 billion parameter model. Now, it is backed by a very thorough research, and I would highly suggest that you are interested, you should read it. Now, in many real world applications, such as multi turn conversations, long document comprehension, and video generation, LLMs must efficiently process long sequential data, understand internal long range dynamics, and generate coherent output. The transformer architecture, despite its remarkable capabilities, faces challenges with quadratic computational complexity and limited inductive bias for length generalization, making it inefficient for long sequence modeling. Even with recently proposed distributed attention solutions, computing a single training step of a 7 billion parameter model over a 1 million token sequence is more than 100 times slower than performing the equivalent computation across 256 separate sequences of 4K tokens each. Techniques like efficient attention mechanism and structured state space model have been introduced to overcome these limitations, aiming to enhance scalability and performance. But the practical application of these models still falls short of transform. This research paper introduces an unlimited context model that outperforms the canonical transformer architecture on real-world language model. And that is called as Megalodon, which is an improved mega architecture that harnesses a gated attention mechanism with the classical exponential moving average or EMMA. To further improve the capability and efficiency of Megalodon on large scale long context pre training, they have proposed multiple novel technical components. First, Megalodon introduces a complex exponential moving average or SEMA component, which extends the multi-dimensional damped EMMA in Mega to the complex domain. Then Megalodon proposes a time step normalization layer, which generalizes a group normalization layer to autoregressive sequence modeling task to allow normalization along the sequential dimension, improving large-scale pre-training stability. Megalodon further proposes normalized attention together with pre-norm with two-hop residual configuration by modifying the widely adopted and post-normalization methods. By simply chunking input sequences into fixed block, as it is done in Mega Chunk, Megalodon achieves linear computational and memory complexity in both model training and inference. Now, to reduce the quadratic complexity in the full attention mechanism, Mega simply splits the sequences of queries, keys, and values into chunks of length. And then the attention is individually applied to each chunk, yielding linear complexity. Technically, the EMMA sublayer in Mega helps capture local contextual information near each token, removing the problem of losing contextual information beyond chunk boundaries in the chunk wise attention. So I believe that in the future, this new research holds a lot of promise, and I think if we are looking for unlimited context and improvement over transformer, then this is a good candidate. I will drop the link to it in video's description, and if you go through its GitHub repo, you will find that not only they have given some installation instruction with PyTorch and the CUDA, where you would have to just git clone this repo, and I'll drop the link in video's description of this repo. Then you need to install the fair scale package. Fair scale package is quite a fine package which is developed by Facebook AI Research Fair that provides various tools and utilities for training these neural networks on models, especially focusing on large scale distributed training and model parallelism. The package includes modules for enabling efficient data parallelism, mixed precision training, and model sharding across multiple devices or nodes. One of the cool things which it can do is model sharding, by the way, which allows you to split LLMs across multiple devices or GPUs. Anyway, once fair scale is done, then you need to install Megalodon, and then it will give you the pre-trained model, and you have to just set some of the D types and tokenizer path. Once that's done, you can launch a job for LLM pre-training by following these parameters and steps which are given in detail. But of course, you would need either multi GPU or a good GPU in order to run it. It won't run on commodity GPUs or CPUs. I already have tried, doesn't work on my 16 GB VRAM GPU. But I think a real good project, and you can also join their Discord channel to discuss it further. I hope that it will, blossom more. Let me know what do you think about this project. If you like the content, please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps. Thanks for watching.